Okay, so welcome back, everybody. So it's great pleasure to open our second day now of this meeting. Just for those of you who weren't here last night, just kind of remind you that the mission of this meeting is to really produce a framework for how we're going to achieve plants in silico as a community. We have, as I said last night, we have many different models of plant processes. We've had an explosion of understanding of how plants work. But to really gain benefit from all of this, we need to be able to have a framework where we can put our mathematical description of all of these processes, from genes and gene expression right the way up to the growth of whole plants and communities of plants, into an integrated framework. And I'm very pleased to be able to introduce this morning Ed Seidel, who is the director of the National Center for Supercomputer Applications, and has a lot of experience in bringing communities together, different scientific communities, in this way. And he'll maybe tell us a little bit about those experiences and tell us about the National Center for Supercomputer Applications. So, Ed.
Thanks, Steve. So welcome, everybody, to if you're from off campus to the University of Illinois, and if you're on campus to NCSA. I don't know how many of you have been here. Just if you're on the campus, just a little advertisement. We have a colloquium series most Fridays for many topics that have to do with generally the applications of computing or various aspects around it, but they're meant for a rather broad audience, and so I hope you'll come for those. So I'm the director of NCSA, the National Center for Supercomputing Applications, and I'm very excited about this project and about particularly this kind of gathering of people from across campus and across the world, because I see it as something that's the beginning of something quite big. And I'll tell you a little bit about my experience in similar endeavors in other fields in a minute. But I wanted first to just say a few words about NCSA itself. So NCSA has been here for 30 years. We're celebrating our 30th anniversary this year, and we're having a number of events across the campus. We had there's an exhibit, by the way, at the Spurlock Museum. If you were to go visit there, you can even see the original proposal that created NCSA. It's in a glass case displayed like the Gutenberg Bible is at the Beinecke Rare Book Library at Yale. But it's a sort of a signature for what NCSA stands for, which is a lot of bold thinking. So that proposal was written by Larry Smarr, who was at the time an assistant professor in the astronomy department here, was something like a $14,000 grant. And he was tired of having to go to Germany, to the Max Planck Institute in outside of Munich in Garching to do his computing. He was working on the problem of two colliding black holes. So he came back and he wrote, first of all, a very provocative white paper called Supercomputer Famine in America. And then he wrote an unsolicited proposal to the NSF for about $40 million and said we have to have a supercomputing center to support sciences across the country in the U.S. And in fact, saying that Max Planck, I know this because I gave a talk in Berlin last week and I sort of highlighted a piece of Larry's proposal that said the Max Planck Institute, or the Max Planck Society, is a model for the United States. And it was around supporting communities to do complex problems that required simulation and modeling at the time. And so that proposal actually didn't only create NCSA, but it created 5 national supercomputing centers that have really changed the culture of science across the country and I would say across the world. So NCSA is a home of quite bold thinking and big projects. And so I've come here, I was a postdoc of Larry's, and so my background is general relativity and black holes and so on. So I came here 2.5 years ago as the director. And my first priority is really to make sure that NCSA maintains its top-level leadership at an international level in providing the capabilities to do science around computing and increasingly data that you can't do anywhere else because we just have such extraordinary facilities. For example, we have the Blue Waters supercomputing facility. If you, I don't know if there's a tour that's arranged or could be, but if you're interested in seeing it, it's on the other side of campus. It's in a building. The building itself that houses the machine cost $100 million, to give you an idea of the magnitude of how big this facility is. It has about 500,000 processors. It is the largest facility that's operated for academic use in the world, certainly on an academic campus. But it's not just about the computer, it's about the people. We have a staff of about 200 experts in not only the operations of that, but in the support of scientific communities across all disciplines. We have enormous amounts of storage and bandwidth. We have, just if you're into this, we have a 400 gigabit connection between the building and Chicago. We have hundreds of petabytes of data storage. And that sort of provides the ability for us to do many other things. For example, we are developing the data services pipeline for a thing called the Large Synoptic Survey Telescope, which is a project funded jointly by the NSF and the DOE. I actually oversaw this project, among others, when I was at the NSF. I led the Directorate for Math and Physical Sciences, so there are many of these sort of so-called Emory of C projects. This is a project of about $1 billion, and NCSA is actually part of the construction project for that. The telescope is merely a peripheral to the data services that are being provided, and so we are developing that. So that kind of expertise can be brought to bear on any discipline. And so as we build up NCSA and its staff, and we just recently hired the person from NSF who ran the Software Institutes program. In fact, we've hired the last two people to run that Software Institutes program at the National Science Foundation, who really deeply understand how you bring together communities around entire institutes devoted to software to support advances in science. And so the connections to the other agencies are available, and so we kind of understand how this all works. And so the point is, NCSA has this kind of facility, and we are very happy to be able to support and embrace this project because we think it has a long way to go, and there's a lot we can do to help it achieve its goals. About NCSA's intellectual environment, we have been building interdisciplinary research teams very aggressively in the last 2.5 years. It's always been a home for interdisciplinary research, but in the last 2.5 years, we've created 6 thematic areas that now have over 80 faculty affiliates from across the campus, across virtually all the colleges and disciplines of the university. We have over 20 what we call core faculty, where we have offices in the building. And in these 6 thematic areas, one of them is called computational biomedicine and life sciences. And so this project is one of the projects that's supported within that particular thematic area. But there are other thematic areas as well, and they're mutually reinforcing. So we have a thematic area on computing and data, where we're thinking a lot about how, for example, software environments could be built and new algorithms could be brought to bear on advances in computing and data and so on. So these can be mutually interacting. We have another one called Earth and Environment, where we have a number of groups around Xiaowen Wang's efforts on cyber GIS and others. And so you see how these provide a kind of an ecosystem of interdisciplinary research groups that are themselves mutually reinforcing. So I'm very interested in hearing from you what we might be able to do to support your project going forward in a very big way. I'll mention one other project that's related. NSF has recently funded a set of things called data hubs, and so there are 4 of them across the country now: the West, the Midwest, the Southern, and the Northeast data hubs. I am the PI of the Midwest Big Data Hub, and we're just getting started, but our plan is to develop a number of what we call spokes, which are basically themes that support complex, grand challenge, community-type projects. For example, food, energy, water is one of the spokes. We have 11 states in our region. Most of the universities in the region are working with us. So one of the areas would be food, energy, water. Another one is precision agriculture. Another one is metropolitan science. And they have needs to share data that bring different communities together, from chemistry and physics communities to communities who know about soil conditions, to people who are worried about how would you collect data from unmanned aerial vehicles or from satellites and serve it up in a way. And so NCSA has the facilities to also bring all of those things together. So I would love to hear from you how we might be able to customize some of the things we're doing to support your project better. So let me conclude by just saying a couple of words about my own experience and how that might be useful as well. So my background is general relativity and black hole modeling, which you might think is quite distant from what you're doing. But in fact, we were just talking with Mark. I was a professor at the Max Planck Institute for Gravitationsphysik in Gulm, right next to Pflanzenphysiologie, which I know the German name. I don't speak German very well, as you can hear if you speak German, but we actually took up part of that institute at one time because we didn't have enough space at the AEI, also known as the Albert Einstein Institute. And I launched some projects there that involved many different communities across many countries. And in particular, one was a modeling in relativistic astrophysics, like looking for things like how would you understand what a gamma ray burst is. So the thing you need to know about that is there are many sub-communities that basically don't talk to each other very much, but all of their knowledge is needed to understand what a gamma ray burst is. You have to know about general relativity. You have to know about hydrodynamics. You have to know about magnetic fields. You have to know about radiation transport, nuclear equations of state, initial data for neutron stars and black holes, and about astronomy, and about numerical methods, and about simulation and modeling, and about parallelization and visualization, and so on. And there's no way any one group knows how to do that. So we had funding at the time from the European Commission and from the Max Planck Gesellschaft to create a framework, a modeling framework that allowed those groups to work together. In fact, we had groups from over 10 countries working together, and we developed a modeling framework that allowed every one of those individual groups to develop their individual activities, but then to collect them to study much more complex problems. And there was a very good intellectual model for this. People could do their own work without feeling like they were being overtaken by others, but they can contribute as they liked to a larger whole. And I see the Plants in Silico project having many of the same kind of features to this. And at the talk I gave last week in Berlin, by the way, last week there was the 75th anniversary, May 12th, 1941, of the invention of the programmable computer by Konrad Zuse. And so I gave a talk there about the interaction, particularly between Konrad Zuse and Albert Einstein's work in particular, and how that led ultimately to the routine solution to the most complex equations in all the mathematical physics, Einstein's equations. It took a century for that to happen, but because of the modeling framework that we and others put together, any graduate student in the world, and there are now 15 countries using this particular simulation framework in that area, can solve Einstein's equations routinely, stuff I couldn't do for my entire career. Okay, so now, any student can get this started. So perhaps we could do something as grand as that with this group, and I'd love to hear from you how we might try to do that. So I'll pass it on to Evan. Evan is next.